The thousands upon thousands of structures that sparkle at us on starry nights in the firmament make us aware of how small we are in the overall galactic context. What undiscovered worlds might still be slumbering in the gigantic expanses of the universe? Which entities, and possibly life forms, are waiting to be tracked down by our earthly eyes? With every discovery that experts make in the cosmos, we add another piece of the mosaic to the overall picture of the universe. It becomes particularly exciting in those cases where researchers come across entities that are hiding in the remotest corners of the universe. Find out how scientists recently succeeded in identifying the most distant star of all time and what other astronomical discoveries made the headlines. Are you excited about the groundbreaking discoveries and fascinating spectacles in the universe? Then remember to subscribe to Simply Space and click the bell for regular updates on these topics. By giving us a thumbs up, you're motivating us and showing that we can keep you compelled with the content of our posts. In the solar system, no other celestial body comes close to the impressive dimensions of our central host star, the Sun. The Sun has a diameter of just under 900,000 miles. To put this in perspective, our blue home planet, Earth, would fit inside our bright parent star over 1.3 million times. However, the mass of our Sun is nothing compared to the isolated star that experts were recently able to locate with the help of the Hubble Space Telescope. Researchers estimate the mass of this celestial body to be 50 to 100 times that of the Sun, making it shine millions of times brighter than our central star. It's well known that light from distant stars sometimes takes billions of years to reach our Earth, and this is also the case with this exciting new discovery. Before the emitted light reaches us, it travels the gigantic expanses of space for about 12.9 billion years. In other words, this star already existed when the universe was just 7% of its present age. After its discovery, the celestial body was christened Arendelle. This term has its roots in Old English and means something like rising light or morning star. Why the discovery of Arendelle, which was formed just 900 million years after the Big Bang, is a real sensation becomes clear when we consider the following. Normally, such distant and thus old stars can no longer be identified individually. They are typically much too faint. That we could nevertheless add Arendelle to the star maps is thanks to the so-called gravitational lensing effect. In the world of astronomers, gravitational lensing describes the deflection of light by large masses. Basically, the light from a distant source, such as a star or galaxy, is affected by an object that appears to be in front of it. In this case, the light deflected by such a gravitational lens is bent toward the mass to a greater extent the closer it passes to the cosmic lens. Although Albert Einstein predicted the gravitational lens effect as early as the 1930s, several decades had to pass before the phenomenon was observed and officially confirmed. In the meantime, experts are taking advantage of this effect and some of its variations to identify a wide variety of remote objects. When particularly massive galaxy clusters act as galactic lenses, the bodies behind them sometimes appear as multiple images. For this reason, a star in the constellation Pegasus greets us 4 times from the firmament. With the help of the gravitational lensing effect, experts have succeeded in detecting single, separated stars in the past. Until now, however, the search for such distant objects was subject to a fixed limit. Anything further than 9 billion light-years from Earth could not be identified. Consequently, Arendelle's distance of 12.9 billion light-years also sets a new record. In the course of their discovery, scientists received help from a galaxy cluster in the foreground. This amplified the starlight 1,000-fold, enabling Hubble to capture Arendelle in an image. The initial discovery of this celestial body should lay the foundation for further, more informative investigations. Through spectroscopic analyses by the James Webb Space Telescope, experts hope to reveal some fundamental characteristics of this distant star. These include, in particular, whether Arendelle was a single star or part of a binary system. This exciting research is like a cosmic journey into the past. Due to its presumed large mass, the object has probably long since exploded. Still, Arendelle serves as a cosmic milestone in the exploration of the universe's early history. The year was 1992 when a team led by Polish astronomer Alexander Wolszczyn identified the first 2 exoplanets in history. Now, 30 years later, scientists have reached another milestone in this exciting field of research. They succeeded in cracking the 5,000 mark for known exoplanets. In fact, experts were recently able to add 65 previously unknown extrasolar planets to the star charts. Exoplanets are planets located outside the solar system and gravitationally bound to another host star. The fact that our distant cosmic neighbors can be drastically different was proven by the first discovery in 1992, when experts discovered two planets orbiting not a sun-like star, but a rapidly rotating pulsar. From then on, it became clear to the experts that if planets can exist in the realms of such a neutron star, they could occur practically everywhere. This assumption has proven to be true. In the past few decades, scientists have tracked down thousands of additional exoplanets. Although we now know of the existence of more than 5,000 such celestial bodies, it's estimated that billions more planets are waiting to be discovered, and that's just in our own Milky Way galaxy. Even more exciting is the fact that every second potential host star could serve as a gravitational fixed point for an Earth-like planet. In other words, with every new exoplanet discovered, the chances of finding extraterrestrial life increase. While the future promises to uncover countless planets and objects, we shouldn't forget that even the celestial bodies we already know are still accompanied by big mysteries. Among these is a mysterious phenomenon that astronomers recently detected on the Sun. This concerns a new form of high-frequency plasma waves that cannot presently be assigned to any comprehensible context. As part of these processes, asymmetric vortices are formed near the solar equator, which then move in opposite rotational directions around our parent star. The researchers were particularly astonished by the fact that these plasma vortices move 3 times faster than all previously known solar waves. What underlies this unexpected phenomenon remains completely uncertain. One thing is certain, however, due to the temperature differences in the interior of the Sun and the interactions of plasma with the magnetic field, gravity, and self-rotation, wave-like instabilities in the plasma occur repeatedly on the Sun. But in the case of these new observations, previous explanations reach their limits. After analyzing data from a 24-year-old study, astronomers realized that this unknown type of plasma wave extends practically around the entire Sun. It forms a coherent composite of vortices that rotate alternately clockwise and counterclockwise. Experts remain completely in the dark as to the cause of this phenomenon, which adds to the growing list of unanswered questions about our own star. The fact that so-called cryovolcanism exists in our solar system is not a new discovery. Cryovolcanoes have already been detected on several icy moons orbiting the planets Jupiter, Saturn, and Neptune. As their name suggests, cryovolcanoes do not spew boiling hot lava, but rather easily meltable substances such as methane, water, ammonia, or carbon dioxide. These substances exist in the interior of celestial bodies in a frozen state, and heat causes them to melt, allowing them to make their way to the surface. Once on the surface, these substances solidify again, piling up to form deposits many hundreds of feet high. The evaluation of data from the New Horizons space probe over Pluto suggests that this former member of our planetary system harbors a form of ice volcanism never observed before. First, however, a fundamental question had to be addressed: do ice volcanoes exist on Pluto at all? To solve this mystery, experts studied 2 promising candidates, massive mountains culminating in gigantic crater plains. After analyzing the data and images, it became clear that Pluto's mountains do not have much in common with classic ice volcanoes. With diameters of up to 33 miles, the summit depressions are too large and too irregular to have collapsed in the traditional sense. Furthermore, the scientists found no traces of ejected material. The entire surrounding area is adorned by elevations many hundreds of feet high and up to 12 miles wide, a circumstance that appears extremely unusual for conventional ice volcanoes. More intriguing is the fact that the terrain shows practically no impact points, suggesting that the corresponding region is relatively young. This hypothesis aligns with the fact that the mountains studied consist largely of frozen water ice with a thin mantle of organic deposits, frozen methane, and nitrogen ice. The different thicknesses of the layers indicate that different parts of the area were not formed together but at different times. What could be the origin of Pluto's mountains? According to researchers, the area is the result of a unique form of cryovolcanism. Initially, viscous but mobile water ice flowed to the surface, creating huge elevations. Later, the individual hills merged to form the coherent hilly landscape that Pluto presents to us today. If this exciting theory is confirmed, it would also suggest that Pluto is significantly warmer in its interior than previously thought. In fact, the internal heat would be the basic prerequisite for water ice to become mobile enough to slowly emerge from the subsurface.